Let's talk about rational functions. So you remember a rational number is an integer divided by another integer, right? A non-zero integer. So a rational function is actually a polynomial function divided by a non-zero polynomial function. So 8x squared plus 3x minus 7 over 9x to the 7th plus 2x minus 4. That's an example of a rational function. Now, if we're trying to understand rational functions, probably this is not a good place to start. We should start with the simplest rational functions we could come up with. So how about f of x equals 1 over x? Technically 1 and x are both polynomials, so this is fairly simple. Now you could make a table for this. And the nice thing about this is your table values would be fairly simple. If you put in a -2 here, you get a -1/2, -1. Here, notice you get something undefined, and here you get 1 and 1/2. So if you were going to plot this, you would get something that would look like this. Now, what's going to happen in between here? That's a good question, and what you need to do to answer that is you need to plot some points like 1/2 or -1/2. Notice if you put 1/2 in here, 1 over 1/2 is actually 2. 1 over -1/2 is -2. Convince yourself of that, but that gives you dots that are right here. You could keep going. At 3 it's a third, at 4 it's a fourth, and what you'll see is you get a graph that looks like that. In particular, it gets really close to 2 lines. These lines are not part of the graph, but we draw them anyway. This is called a vertical asymptote. This is called a horizontal asymptote. And you can see that the function gets close to those as we go forward. Now, the nice thing about understanding this is if you wanted to use what you know about transformations, we could move this to some other shape. So for instance, f of x equals 1 over x minus 2, you can recognize as a horizontal shift to the left by 2. So you would have a horizontal and a vertical asymptote, and the graph would look like this. Or you could have f of x equals 1 over x minus 2 plus 3, right? Now, often what we'll do is we'll actually write this as a single term. How do you do that? You get a common denominator. And so you might see something that looks like this. Minus 5. You see this, but you know that what's happened is this graph has just been shifted up 3. So this is an example of how rational functions look often. Now, a rational function will have vertical asymptotes often, but they don't always come up and down. Think about this example. Ooh. What about 1 over x squared? Now, if we plug these values in, we can see, again, what happens. If you plug in -2, now you get out 1/4. -1, you get out 1. At 0, you still get something that's undefined at 1, 1, at 2, 1/4. These interesting points we mentioned before, if you plug in 1/2 squared, you get 1/4. 1/1/4 is now 4. And 1/(-1/2 squared is still 4. So what you get, if you plot these dots, you get dots that look like this. In other words, what's happening? You still have a vertical asymptote at the line x equals 0. You have a horizontal asymptote at y equals 0. But now both sides shoot upward. You could also shift this picture right or left. I'll just give you 3 more examples here. So here are 3 quick rational functions examples. Notice here, if you looked at the y-intercept, you'd plug in x equals 0 and you'd have that point. That's also the x-intercept. So we know that it goes through that point, but we know that we have a vertical asymptote. We don't happen to have any horizontal asymptotes, more on that in another video, but this is what the graph ends up looking like. Here, notice my numerator is just 3, so there's no way that the numerator can be 0. In other words, we don't have any x-intercepts whatsoever. we do have vertical asymptotes at 2 and at -1, so you can sort of see how that picture would go together. We also have a horizontal asymptote at 0. Again, there's another video to talk more about horizontal asymptotes. Last but not least, notice this picture. We have 2 zeros. Those are places where it crosses the x-axis. One is at +1, one is at -3. Then I have 2 vertical asymptotes there. I have a horizontal asymptote at y = 1. And so this is what the graph ends up looking like. This is just to familiarize you with rational functions in general.